The next one, n of a is equal to n of a minus b plus n of a intersection b. So what we will do is, we will draw the Venn diagram. Why this plus came? Because it is number of elements in a minus b plus number of elements in a intersection b. With the help of Venn diagram, we will be showing that the sets are equal. Okay, if the sets are equal, number of elements will be definitely equal. So this is a and the set is b. N of a, you know that this is a circle. The circle will be n of a. So I will go to the RHS a minus b, which is a minus b. We have to avoid a b from set a. So this is a minus b. Okay, A intersection B, which is A intersection B. I always say that intersection is the lens-shaped region. So this one. Okay, the union of these two, green colored portion and a magenta colored portion, will give you A. That means A minus B union A intersection B gives you N of A. A minus B union A intersection B. A minus B union A intersection B gives you the full set A. So if I represent in terms of number of elements, I can say that number of elements in A is equal to number of elements in A minus B plus number of elements in A intersection B. Again, the next one, number of elements in A union B dash is equal to N of U minus N of A union B. Here also we are going to show with the Venn diagram. So this is U, let this be A and this be B. N of U means the full set. U means the full set. So N of U means the full elements in set U. And A union B, which is A union B. A union B is this shade. So that, and the right side says that N of U minus N of A union B. We are not taking the number of elements. We are just taking the sets U minus difference A union B. U difference A union B. U is the full set. So that, and A union B is the magenta colored portion. So A U minus A union B will be the green colored portion. So that is what A union B the whole dash. And the statement says that N of U, number of elements in U minus number of elements in A union B, will give you number of elements in A union B the whole dash. Both represent the same sets. That means number of elements will also be equal. Again, the next and the most important one is N of A union B is equal to N of A plus N of B minus N of A intersection B. Throughout the chapter again we will be applying this formula. So by heart the formula, N of A union B is equal to N of A plus N of B minus N of A intersection B. So I am drawing the sets. Here also we are not going with the elements, we are just going with the sets. So I will be proving A union B is equal to set A union set B, making the difference with the A intersection B. So A union B, you know that clearly. A union B, here in this figure it is a magenta colored portion. Okay, I will take the right side, which is N of A. N of A is the, I am here shading with the green colored line. Okay, and B will be, I am shading with the magenta colored portion. Okay, and the left side I want to take the set of A union B. A union B means a full set. But can you see here in this region, intersection portion, green colored is there, magenta colored is there. That means intersection portion repeats twice. So if I take the union, this portion will, this portion will be coming, this portion will be coming, and this A intersection B will be coming twice. So we have to avoid one. That is the reason why I am subtracting N of A intersection B. Clear? N of A means it is actually this set, this portion plus N of A intersection B. Okay, so in B also N of A intersection B comes, A intersection B comes. So if I want to find A union B, if I do like this, A plus B, that means A union B, this intersection part comes twice. So to avoid that, we are subtracting the number of elements in A intersection B. Clear? So N of A union B is equal to N of A plus N of B minus N of A intersection B. Otherwise I will make it clear again. Let A is equal to set 1, 2, 3, 4 and 5. What about N of A? Number of elements in A is 5. Okay. Let B is equal to set 3, 4, 5, 6 and 7. 7 and 8. Let it be 5. And N of B is equal to 1, 2, 3, 4, 5, 6. 6 elements are there in N of B. What will be A union B? A union B will be equal to 1, 2, 3, 4, 5, 6, 7 and 8. That means N of A union B contains 8 elements. Okay, so if I add N of A and N of B, again one more thing. Find A intersection B. What is A intersection B? A intersection B is a common for A and B, which is set 3, 4 and 5. And the N of A intersection B will be equal to number of elements in A intersection B, 3. So we are getting N of A union B as 8. Okay, N of A is 5 plus N of B is 6. 5 plus 6 is 11. Minus 3 will give you the value 8. Okay, N of A plus N of B. N of A plus N of B minus N of A intersection B gives you 5 plus 6 minus 3. 5 plus 6 is 11. 11 minus 3 is 8. That is the same as N of A union B. So by heart the relation N of A union B is equal to N of A plus N of B minus N of A intersection B.